Bismillahirrahmanirrahim. I think it's about time because we talked about 6:15, so it's already 6:20. So I think we should start. So this is the second part of the SPSS training. We did our first part on last Friday at 6:15, and in the previous training we covered the basic features in SPSS. What is a questionnaire? How do we put our questionnaire data into SPSS sheet? Then we talked about summation analysis like uh, sample characteristics. Then we talked about the Cronbach's alpha and the reliability test. We also talked about the descriptive statistics tests, in which we discussed the mean, standard deviation, skewness, kurtosis, and then we moved towards our correlation analysis. And between these analyses, we also did the data cleaning part, that how you can detect your typos. And then we also did the variable computation part. So that was actually the start of the SPSS. Today we are going to go for a little more difficult analysis, starting from the regression analysis, and then we'll talk about mediation and the moderation. But while we'll be doing this, the first part will cover the concepts related to these things. For example, what are different variables? We'll, in a very brief way, we'll cover what are the different types of variables, and then we'll talk about what is regression, what is mediation, what is moderation. So we'll try and understand the basic purpose of these path analysis. And then we'll also talk about a few important values that we usually see in our regression analysis, in our mediation and moderation analysis. And then in the second part, we will be actually conducting the analysis using our SPSS sheet. If you want to ask me any question, there is a chat room available. You can always talk to me. Otherwise, I'll try and cover almost everything. But still, if you think if there's anything missing, you can stop me in between, and then we can have a little bit explanation about different concepts. Otherwise, even if you, for example, forget to ask a question during the analysis time, at the end of our session, we're going to have a few minutes in which I'll be able to take your questions, and then I'll be able to answer them. So I think without waiting, we should start with our first part, which is the basic concepts. I'm sure most of you are already familiar with the type of variables, but let's just have a quick review because we want to be very clear what we are talking here. So starting from the mediation and moderation analysis, first we will talk about the different variables. We'll talk about the mediating and moderating variable. We'll talk about the indirect, direct, and total effect. We will also talk about what is moderation, how do we interpret mediation and moderation, and for this purpose, we will be using the process macro, which is developed by Andrew Hayes. So for other mediation analysis, we might be having some other trainings. Like we'll also cover the WARP PLS SAM model and other things. But for now, we'll only be using the process macro. So let's just go to our understanding of the variables. This is a simple theory or a relationship which says that smoking has a negative relationship with health. So if you just look at the statement or this theoretical framework, because this framework is actually describing a theory, so only in this case we can see that health is dependent on smoking, but only in this case. So here in this kind of theoretical framework, we'll call health as a dependent variable and smoking as an independent variable. But again and again, I'm saying only in this case, because health might be an independent variable in some other theory or in some other theoretical framework. Smoking might be a dependent variable in some other framework. And we are only considering in this framework that it has a negative relationship. Maybe some people are, if uh, using the same theory in a different way, then they might have a positive relationship or maybe an unknown relationship. So in this case, you can say that health is a dependent variable and smoking is an independent variable. Uh, Another indication of independent and dependent variable is that usually the arrow is hitting the dependent variable. It is emerging from the independent variable. So this can also be one of the indicators. Therefore, in the health and smoking relationship that we're just discussing now, we have two variables. One is independent and the other one is dependent variable. Now, we'll take this discussion a little further. Let's say that there are two of these variables. That training leads to better performance. So in this case only, the performance is going to be our dependent variable. It's going to be our dependent variable, and the training is going to be our independent variable. So if this is a theoretical framework, it is a simple theory that training leads to better performance. Let's just take this argument a little further and suppose that the other person is saying that training leads to performance, but there is some mechanism which is involved in between these two variables. That is learning. Now, the argument is that training actually leads to learning, and then learning helps in improving the performance. So, although training is our independent variable, performance is our dependent variable, but now there is a third variable that is now known as the mediating variable, because it is mediating between independent and dependent variable. It is also known as the intervening variable. Now, let's just take the same thing a little further and let's just put another variable. That is quality of the trainer, or maybe the preparation of the trainer. Now we have four variables. In this case only, the training is going to be our independent variable. The performance is going to be our dependent variable. Learning is going to be our mediating variable. And quality of the trainer is our moderating variable. Now, why do we call the quality of the trainer as a moderating variable? Because the presence or absence of this variable, this quality of the trainer, will lead to change in the relationship between these two variables. So it's a kind of catalyst. It might enhance or may decrease the relationship between two variables, but the major difference between the mediating and the moderating is that one, which is the mediating variable, this is involved in the cause and effect relationship, or it is having some kind of involvement in terms of the transaction. For example, training is actually affecting the learning, and then learning is actually contributing towards the performance. So these kind of variables which are being affected by the independent variable and then they affect the dependent variables, they are known as mediating variables. But the variables, because of whose presence or absence can change the relationship between two variables, are known as the moderating variables. So you need to be very clear what you're trying to assess here. And for that, you need to have a very clear understanding of what is independent, what is dependent, what is mediating, and what is a moderating variable. We'll further talk about these variables. Now, let's just consider the example of a father, a mother, and a child. And here we are just saying that father gives some pocket money to the mother, which is say $100, and then mother gives $50 to the child. So what is happening here? The father is affecting the mother, and then in the mother is affecting the child. The transaction is taking place from here to here and then here to here. So mother is the intervening or the mediating variable here. But on the other hand, father is trying to give pocket money to his child directly, but somehow the mother shows up. First, she was not present, now she's present. So the father was actually giving $100 to the child, but because of the mother's presence, he gives $50 to the child, which means because of the presence of the mother, the transaction or the relationship between father and the child changed. Which is why, in this case, mother is acting as a moderator. Now, she's not part of the transaction, but just because of her presence or absence, the relationship between two variables is changing. So, this will give us a little bit better idea about what are mediators and moderators. Some more things about the mediator first, because when we'll be analyzing it in SPSS, we'll be using these terms, so we need to have some idea about these terms. Now, let's consider the father is giving pocket money to the mother, and then out of that pocket money, the mother is giving it to the child. Now, this 50 rupees, which were actually coming from the father to the mother and then to the child, are the indirect pocket money. It is coming from father's pocket, but indirectly through mother's pocket. So any effect which is done by the mediator because of the independent variable to the dependent variable is known as the indirect effect. Indirect effect goes like this. This is also known as the mediation or mediation effect. But on the other hand, if there is an effect from the independent variable to the dependent variable directly, this relationship or this effect is known as the direct effect. So here we have two types of effects. One, indirect effect, which is through the mediator. The other is the direct effect, which is from the independent variable to the dependent variable. Indirect effect is known as the mediation. So when we are actually interested in mediation, we are actually trying to see that how this variable is acting between the independent and the dependent variable. And another concept is known as the total effect, which is simply the indirect plus direct effect. For example, here if we can say that father is giving pocket money to the mother and then mother is giving 50 rupees to the child. So this is indirect effect. You can see here 15 rupees which are being given directly by the father to the child without any mediation is the direct effect. That is 15 here. So this effect plus this effect, if you sum them up, so 15 plus 50 is equal to $65, and this is known as the total effect. So you need to keep these terms in mind, because when you'll be looking at those results, you need to have very clear idea what we are seeing and what we are talking about. Now, let's just talk about the regression. Regression is actually uh, we're talking about the linear regression here. Not there are many types of regressions. So here we'll only be talking about the linear regression. We'll also be talking about the relationship and the model. Then we'll be talking about what are some of the important values in regression, and then we'll see how to analyze regression using SPSS. So first of all, what is regression? As we've just understood the variables, so with the help of this regression, we can know the impact or the cause of one variable to the other variable, the impact of one variable on the other variable. You can also say that we can see the impact of independent variable on dependent variables. How do we see it? Based on the data of the variables, a line is modeled to predict the relationship. Now, we'll just look at this example and then we'll have a very clear idea how regression actually works. Here we have two variables. One variable is the years, and another variable is the percentage of adults who smoke. So if you can see here that we have 5 years since 1967, 10 years, 15 years, 20, 25, 30, 35, and 40 years. So this is a data of years. Now this is the data of the percentage of people who are smoking corresponding to these years. So what is happening is, for example, what is the situation after 5 years, for example? So after 5 years from 1967, about 38% of the people are smoking. What about in 10 or somewhere near 10? Uh, Again, about 36, 37, 38% of the people are smoking. In 15, let's say there is a 35. Again, in 25, there is 25. And then in 30, it is even less. And then after 40 years, it is further less. So what regression does is that it actually, based on the data of the two variables, it gives you a regression line which can show you the trend, that what is happening in terms of relationship of these two variables. So here you can see that from 1997 onwards, 40 years onwards, the number of people who smokes are decreasing, because the line is like this. If the line is like this, for example, then you're going to say that number of people who smoke are increasing after 1967. But if the line is, for example, like this, consider it a straight line, we are going to say that it's a straight line. So here, regression is doing this kind of analysis. It is actually trying to fit your data into some one-liner, which is indicating the relationship between these two variables. Then, few more terms related to the regression. Most of the times we're very confused about what is simple regression and what is multiple regression. So simple regression is actually a regression which we run with one independent variable and one dependent variable. Another thing that we need to remember here is that in linear regression, which we are studying and we are going to analyze, there can only be one dependent variable at a time. You cannot have more than one dependent variable at one time. This is a limitation or the requirement of the linear regression. But it is the independent variables that you can change. Change means that you can have one independent variable, you can have two, you can have three, or you can have multiple independent variables, and you can run a regression with the one dependent variable. Now, if you run a regression of obviously one dependent variable with one independent variable, it is known as simple regression. One independent variable with one dependent variable. If you are running the regression like this, it will be known as simple regression. Don't feel uncomfortable, because when we'll be moving towards SPSS, then you'll have a clear idea what we are talking about. But just to give you these concepts, because you should be having some theoretical background. And then multiple regression is that two or more independent variables with one dependent variable, like in this case. Now we're using two independent variables with one dependent variable. So this will be known as the multiple regression. Furthermore, even if you try and increase, let's say we can also take three independent variables. So this will also make it a multiple regression. So two or more independent variables with one dependent variable. So when we run regression like this, then it is known as multiple regression. But normally, when there's only one independent variable and one dependent variable, this is known as the simple regression. Another very important thing I think that we need to cover here is, don't be confused. If you have any question, you can ask me. Whenever we are doing the regression, we are actually testing one model. We are testing one model as well. I know these terms might be alien to some of you, but if you just keep them in mind and try and connect them with the analysis, So you'll have a very clear idea. So whenever you are analyzing the regression, you are checking the model, one model. But in one model, there can be one relationship or there can be multiple relationships. For example, if you look at this example, this is a simple regression in which there is one model and one relationship between IV and DV. Here, it's a multiple regression, but it has one model but two relationships, 1 and 2. Model is still 1, but the relationships are 2. Now let's just take this example and tell me how many models are we testing here and then how many relationships are we testing here. Let's suppose if this is the model, this is a multiple regression in which we are using 3 independent variables and 1 dependent variable. How many models are we using and how many relationships are we using? Okay, I'm waiting for your answers. Okay, there's a question that if we are analyzing the dimensions of the variables, if you are considering those dimensions as separate variables, then obviously it is going to be multiple regression. But if you are taking it as a composite variable, then it's a simple regression. It totally depends on what you're taking here. For example, if this variable is divided into 3 more dimensions, then it is actually a multiple regression. So we have one model, okay, and 3 relationships. Very good. One model and 3 relationships. One model and 3 relationships. Very good. So most of you are right, and I'm glad that you've understood this concept because this is very important. When it comes to analyzing the results, people do not have even this understanding that how many models they have run and how many relationships they are checking. So I'm glad that you have this idea now. We'll also talk about it when we'll go towards our regression analysis in SPSS. Now, some of the important terms related to regression analysis. Although when we'll get some more results, we will also talk about them. But the most important values or the most important things to uh, look in regression analysis are these 4: the R square value, the F statistics value, the beta values, and the T stats with its significance. These are very important uh, values when we will be using regression analysis. Now, another very important difference. If I just cut a line here, R square and F are actually talking about the model that we are analyzing through regression. Model. The beta and the T stats with its significance are talking about, or we'll interpret them in terms of the relationships. You have just answered that we will be using one model and 3 relationships. So these two values, the R square and the F statistics values, they will talk about the model. Beta and T stats will talk about the independent relationships. Okay, now starting with the R square. Keep these sentences in mind because they are going to help you when you will be interpreting your results. The value of R square explains the variation in dependent variable because of the independent variable or variables in a model. Let's suppose if our R square is 0.59, if this is the value of our R square, it means 59% variation. Now, what is the practical side of this? Let's suppose we are saying that smoking has an impact on health. And while we are conducting our analysis, we got our R square, which is 0.59. So this means that smoking has a 59% effect, or smoking cause 59% variation in health. And remember that we always interpret the R square in percentage. In percentage. We never interpret the correlation in percentage or the beta in percentage, but we always interpret R square in terms of percentage variation. There is another little technical thing, that is, I said variable or variables. And as we just talked about, that R square explains about the model. So what if we have a model like this, which has two independent variables and there is one dependent variable? If this is the case, let's say health, and here we are saying smoking and junk food. So if this is the case and our R square value is, let's suppose, if it is 0.75, if R square is 0.75, we will say that smoking and junk food has 75% effect on our health, or 75% of the variation in our health is being caused by the smoking and junk food. So no matter how many variables you add in the same model, the R square is going to tell you that all of these variables are affecting this much percentage, or whatever percentage we are going to get in R square, to dependent variable. Now, let's just read the R square definition or understanding once again. The R square value explains the variation in independent variable because of the independent variables in a model. That is why R square is an important value that we have to look when we are doing our regression analysis. Then we have the F statistics. F statistics is actually talking about the model fitness of regression. But we'll also look at the level of significance. We'll talk about it. But it is about the model fitness. And as we said, that F, just to remember, just remember F for fitness. And there's also one, in a layman language, you can also remember f as 4. We'll talk about it. Why do we call it 4? Okay, we have a question that how do we know that how much variation is being caused by one variable? That if you're running a simple regression, then R square is also applicable, but beta is going to tell us that. So we'll just talk about it in a minute. So your R square and your F stats value are talking about the model. And if your F stats value is above 4 or 3.75, then we can say that our regression model is fit. But the beta and the t-test, these two explain the relationship portion of the regression. For example, beta value is going to indicate that with one unit change in independent variable, beta units will change in dependent variable. I know this might be confusing at this point of time, but just try and remember them, and then we'll see what happens in SPSS analysis. So just remember that it is a unit change. Beta is a unit change in dV because of IV. Unit change independent variable because of the independent variable. So we'll talk about it when we'll go to our analysis part. Then we have the T statistics. It is also known as the t-test. And just to remember for now, you can say that if your value of t is above 2, and remember t for 2, just as a sign of remembering the values, if your value of t is above 2 with plus or minus sign, any sign, but it has to be above 2, then you are going to accept your hypothesis, or some people say reject your null hypothesis. Accepting your main hypothesis also means rejecting your null hypothesis. So we'll also talk about it when we'll do the analysis, but just to make you remember a few things. Now, I hope till now we don't have any question, because if you have a question, please ask me. Now we are moving towards our SPSS analysis. So I don't think we have any questions till now. Okay. Uh, we have already computed our variables, and in the computed variables, we can just see that we have some computed variables which are formalization, creativity, innovation, culture, performance. These are some of the variables that we have computed from our uh, items, which we talked about in our last training. Okay, there's a very good question that some books and uh, Papers have mentioned the value of t as 1.96. Kindly clear it. Now, if you talk about the exact value, which is a significant value, that is 1.96. Actually, what happens is, uh, how do we have to understand this thing is that okay, when your t value is increasing, your significance value is decreasing. Not significance is not decreasing. The probability value or the significance value is decreasing. We talked about it in when we were interpreting our correlation. So at exactly 1.96 value of t, the p value of t goes to 0.05 exactly, and 0.00000. So this is the threshold that we'll just talk about, that this is the threshold of accepting your significance level. So if your significance is equal to or less than 0.05, then we say that uh, it's a significant value. So when it reached to 2, 3, 4, then this value is actually decreasing. This is going to 0.049 maybe, and then 0.04, or then eventually 0.00 at somewhere 5t value. That is why we say that at t value 1.96 is the significant value. Yes, anything above 1.96 is acceptable, but just to round it off, we say that it is 2. And it is also easy to understand with t is equal to 2. This is the reason. We'll see when we'll do the analysis that how these significance values are interpreted. Now, here we have our SPSS sheet, and to perform your simple regression or multiple regression analysis, you need to go to this analyze, regression, and linear. If you want, you can note this down. Analyze, regression, linear. So once you will click this linear button, it is going to give you this window. I'm repeating it once more. Analyze, regression, linear. And you can see there are other types of regressions like probit, logit, multinomial, binary logistic, etc. But we'll be using the linear regression. So once you click this linear regression, there's going to be this window which is going to give us the options that what do we want to do in our regression analysis. If you can just look at this, it's written dependent variable or dependent. And if you can look at this, it is known as independent. Now, one interesting thing. I want to run a relationship between creativity as my dependent variable and formalization as my independent variable. So if I do this, just note that it's not allowing me to insert more than one dependent variable because it's a linear regression. So it will only allow us one dependent variable. But if I want to include any number of independent variables, it's not going to say no to it. But for now, I am only going with one independent variable and one dependent variable. So this is going to be what kind of regression? Simple or multiple? I'll be waiting for your answers. One independent, one dependent variable. Okay, we got one answer that it's a simple regression. Good. So when it's a simple regression, if we just click OK, we will get a few tables, like these three tables, and we'll get a few results. So let's just look at these three tables and note one thing, that we have one value of R square, which is 0.162. We have one value of F. Now this is indicating that obviously at one time we only run one model. Fine. Here, if we go to this third table, which is known as the coefficient table, ignore this constant value. Ignore this constant value. If you'll have a question about this, we'll be able to answer it towards the end. But let's just take the value which is in front of this variable, which is formalization or forma. I've just written as an abbreviation. We have a beta. Obviously, this is also the beta value, but we have a beta here that is saying minus 0.367. Okay, we'll just talk about it. And here we are having the t value that is minus 6.934, and here we are having its significance value. Now, because it was a simple regression, it gave us, and we were running one model and one relationship, it gave us one R square value, one F value, and one beta value. Let's just take it to a multiple regression. I'm just supposing that I have two independent variables. For example, I'm also interested in knowing the relationship of culture and formalization with creativity. So the moment I click this one, it's going to give me some new tables in which it is saying R square is there, F is there. Now, if you can see that we have two betas, minus 0.305, 0.471, and then we have two t values in front of these two independent variables, and it is saying dependent variable is creativity here. That means we are using multiple regression with two independent variables. Let's suppose we are using multiple regression with many of our independent variables. I'm just putting them as independent variables, and there's one dependent variable. So this time it's going to give us a lot of results, a lot of beta values and a lot of t values. So this is how you're actually running the regression analysis. Now let's just go back and we will start the interpretation, and this time we are only running it with two variables, and it's a multiple regression in which we'll be using one model but two relationships. So let's just click OK. You don't need to change anything. It's all set by default. And here, if you can see the value of r square, the r square value is 0.346. R square is 0.346. Can any one of you tell me what do we mean by this value of 0.346? I'll be waiting for your answers, that what do we mean by this value of r square? The value is 0.346. I'm going back to the concept of r square value so you can have some understanding about it. If you want, we can have another look at our SPSS output sheet, and the value of r square is 0.346. What do we mean by this value? That 34.6% variation, 34.6% variation, or percentage is dependent variable to the independent variable. Okay, right. Both of you are right. Okay. Okay, fine, good. So most of you have this concept that what do we mean by r square? Okay. A 34% variation in dV because of how many IVs? Because of two IVs. Because of the formalization and because of the culture. Now, the next thing that we have to look is the F value. F value and its corresponding significance value. F value is 65.244. This means, and looking at the significance value, we talked about the significance value in our correlation topic, that the lesser it is, the better it is. How less it should be? It should be less than 0.05. And 0.000 is definitely less than 0.05. So this F is saying that model is fit for regression, or the regression model that we just tested is fit. So these two are going to give you the answer to your model fitness. Okay, we are getting the right answers about R square. Now, another important thing to understand is that the coefficients are giving us the results of our relationships. Which relationships? Relationship of formalization with creativity, relationship of culture with creativity. So, in terms of formalization, it is saying, let me just copy and paste it and make it a little bigger so we have a very clear look at it. So these are the coefficients that we got from our regression analysis. Okay, we have to look at these two values. Here we have formalization as one independent variable, culture is another independent variable, and creativity is our dependent variable. Now, the relationship between formalization and creativity can be seen here. And the relationship between culture and creativity, this is a creative culture, and creativity is here. So now, if we just look at this value, which is the beta value, unstandardized coefficients, we take the unstandardized coefficients. The formalization and the creativity relationship is saying that in 1 unit change in the formalization, 0.305 negative units will change in creativity. So formalization are the rules and regulations that you put in a company. Now, by this we are saying that if we are increasing formalization 1 unit, it will lead to decrease in minus 0.305 units. So the negative sign is telling us the negative unit change in dV because of IV. 1 unit change in IV will cause beta unit change in dV. And what about standard error? For now, or just for the sake of understanding, you can just say that it should be far less than your beta value. And it is far less than your beta value, therefore it is fine. Then we are going to look at our t values and their significance. The t values are minus 6.424, which is above 2. I said with plus or minus sign, which is above 2 definitely. And the significance is definitely less than 0.05. Therefore, we can say that formalization has a negative relationship with creativity. If this was our hypothesis, we are going to accept our hypothesis. We have the beta that is saying 0.471 and t value which is saying 8.318. Look at these results and just give me the answer that what is happening here in the culture and creativity relationship. I'll be waiting for your answers quickly. I am writing down some of the questions that I'll be answer afterwards. Okay, we have one answer. I hope everybody else also understands that culture with 1 unit change in culture, take uh, any unit of culture and just suppose it and that is going to create 0.471 units change in your creativity. So this is how we actually interpret our regression results, and here we can see that the value of t is above 2 definitely. Therefore, uh, we can say that it's fine, and we are going to accept our hypothesis. Yes, most of your answers are, obviously everybody who's answering is right. Yes, very right. So this is how you actually interpret your regression results. And please keep in mind that this is the coefficient. We will talk about this coefficient in the mediation and moderation analysis as well. So keep this coefficient in mind. Now, there were some questions. For example, we require R square value to be above 4, and 65 is too much. Fine. If it is too much, it is still fine, because as long as it is significant, and obviously higher the value of f, higher will be the significance. So that is fine, that is totally okay. Even sometimes for some models this value of f comes in thousands, so even that is fine. So 65 is not a bad value. And r square and adjusted r square, actually adjusted r square uh, is the value of r square, but slightly adjusted, keeping in mind all the errors and other things. So adjusted R square, you can take the adjusted R square for our type of data, which is 5-point Likert scale. You just take the R square. For some other types of data, you take the adjusted R square, but R square is fine. Yes, that is totally correct. That t value more than 2 means we accept out our hypothesis against null. Yes, that is right. But this might not be the right way of saying it, because the right way of saying it is that if your t value is significant, although above 2 is significant value, but I think it should be right that if you say that your t value is significant, saying that it is above 2, it a little, it's a childish interpretation. So you can say that your t value is significant. Therefore, you reject the null hypothesis or accept the hypothesis that you've made. Is the same thing. These days, we do not actually go for making null hypothesis in social science research. That is why, if you look at some papers, you will only see one hypothesis, which is written as H1 or H2, H3, and there's no null hypothesis involved. So this is some of the things about the regression, simple and multiple regression. Now we will move towards our moderation and mediation analysis. And for that, I just want you to look at this model, this one, and just note it down, or you can just keep it in mind that we will be analyzing uh, as formalization as our independent variable, creativity as our mediating variable, and innovation is as dependent variable. You can just write down the IV, MV, and the DV. So this is the model that we'll be testing. So just to remind you again that effect which is going from here through the mediator to the dependent variable will be known as the mediating, and from formalization to innovation it will be known as the direct effect. And this we will be using as a moderator. We'll be taking education as our moderating variable and formalization and creativity. Or let's just change them a little and we can go with this one. Forget about those one because there was a negative relationship. So let's just go with this model. In this model, we will have the creativity as our independent variable, the innovation as our mediating variable, and the performance as our dependent variable. And in the moderation analysis, we'll talk about creativity as our independent variable and innovation as our dependent variable. Okay. Before we move on to our mediation and moderation analysis, you can just look at these things. For mediation analysis, we are saying that we are using model 4. And for moderation analysis, we are saying that we are using the model 1. I think 1 is not that clear, so let's just move this thing somewhere here. Now it'll be clear. So for our moderation analysis, we are saying that we are using model 1, and for our mediation, we are saying that we are using model 4. Now, why do we say these things? What do we mean by these model 1, model 4, model some other models? Actually, as I told you that we'll be using the Andrew Hayes process, macro process, for analyzing our mediation and moderation. So when we talk about the mediation and moderation using Andrew Hayes models, what is the issue and where do we have to get these numbers from? It's a template. By the way, I have given the link in this video where you can just click and download the macro process for using it for your mediation moderation analysis. So within that package, you're going to get this PDF file, which is known as the templates. So when you look at the templates, you're going to see that model 1 is given for a simple moderation analysis. This is showing us a simple moderation analysis, and it says that model 1 should be used. Now, when we move towards some more models, you're going to look at, for example, if we have a model like, if we have a moderation like this, that we have two moderations between relationship of independent variable, is going to say model 2. Then if we'll move here, for example, this is known as moderated moderation. We'll talk about it in some other training or video, but this is model 3. But if you look at this one, this is our simple mediation model. This is saying model 4. So as in this video or in this training, we'll be talking about simple moderation and simple mediation. We will be using model 1 and model 4. So you can just click the link below after the training or maybe during the training, and you can download that macro process. I'll also help you in installing the macro process I will also share the link with you, and if you're going to ask, I can also tell you within this training. So these are the reasons we are saying that we are using model 4 or model 1. The other thing that we need to note here is x, y, and m. So x is our independent variable, y is our dependent variable, and m is our moderating variable in case of model 1, and m is going to be our mediating variable in case of model 4. Even if you're not understanding right now, you'll be able to get it when we'll move towards SPSS analysis. Just to keep in mind that this is why we are saying we need to be very careful when we are using model 1 or model 4. Okay, so let's just go to our SPSS analysis and keep this in mind that creativity, innovation, and performance are our variable. That is why I have given the name of X, M, and Y. So X, M, Y is the name given to our independent variable, mediating variable, and dependent variable. Okay. If we move here, we have the creativity, the innovation, and the performance. These three variables have already been computed. So let's just go to our analysis window. And how do we perform our Andrew Hayes analysis? Is by going to the Analyze, Regression, and Process by Andrew Hayes. Now make sure that you have installed this process. If you have not installed this process, it will not be shown in this window. As I told you that I've already given you the link, and I'll also share the video with you to how to download this process macro. Unless you download and install it, it's not going to be here. It's a separate file. It does not come with your normal SPSS. So make sure you have installed it. So once you have installed it, you can go to this Analyze, Regression, and Process by Andrew Hayes. So click this one, and there's going to be this window. Now, this window has a few things that we need to understand before we start analyzing our moderation and mediation. Here you can see there is this outcome variable which is given as y, independent variable which is taken as x, and m variable which is taken as either mediating or moderating variable. We'll just have a look at it. Now here we have all of our data which we can analyze, and here is the model numbers here. They go up to model number 76. So what we'll be using model 1 and model 4. By default, it is usually model 4, but if you have to change it, you'll have to change it from this drop down menu. So let's just first analyze our mediation analysis, and let's just keep it to 4. If we are keeping it to 4, this m variable will be considered as the mediation variable. Independent and dependent will remain the same. But if we'll consider it 1, now this window is for the moderator. So make sure that you have the right model, because otherwise you will not be able to analyze your mediation or moderation properly. And there are some more windows, which is, for example, W, Z, V, Q. These are used for other models of Andrew Hayes. Now, as we said that we will be taking creativity as our independent variable, innovation as our mediating variable, and performance as our dependent variable. Now, very important thing here. Most of the times, when you do not have some idea about this process macro, it can give you some errors. And one of the errors that it gives you is that if you have your names of the variable having more than 8 characters, then it's not going to analyze your mediation or moderation. So that is why I have given them name with less than 8 characters, which means that if I would have written performance, the full name, and if it would have gone above 8 characters, this macro will not be analyzing it. Okay, I'll explain the purpose of bootstrapping and Herman common bias. We will talk about it, how to do the common method bias towards the end. We'll do that analysis. Uh, Bootstrapping. Now, bootstrapping is a technique which was not available in the in simple SPSS, but in modern softwares, the bootstrapping technique is used. Now, bootstrapping technique, uh, to simply understand it, is it bootstraps your sample. It makes different combination of your same sample. For example, if you have this sample and you say that it should be iterated or bootstrapped 1,000 times, it means that it's going to take this data of your sample, which is, let's say, it's for 250 respondents, and it is going to resample it. How many times? 1,000 times. Resample, resample. So that's going to make it a more rigorous analysis. You can also change it to, for example, 0 up to 50,000 bootstrapping. So 1,000 is also enough, and this is just to correct the biases. For example, if you are collecting data from some people who you think uh, or your sampling method is thought to be little biased, so this bootstrapping is going to cover that error. For example, if you say in your research that you will be collecting your data from Pakistan and you have only collected data from 1 or 2 cities, so bootstrapping is going to bootstrap it, resample it multiple times. How many times? Let's say 1,000 times, and then correct this thing that you have collected data from less people. It's going to resample and resample, and then it's going to give you the analysis. So once you have all of these things set in, for example, mediation, you can go to this options and just put the effect size and total effect model, or let's just leave the effect size, just uh, get the total effect model and continue, and then click OK. It's going to take some time. You just need to see if it is running matrix. If it is running here, that means it is taking its time, but after some time it's going to give you these kind of tables. So how to read this table? First of all, if you, let me just take it to some other file and we can see that if we can see it more clearly. I think it is a little more clear. Now, Starting from this run matrix procedure, it is saying that it has been developed by these people. Obviously, we're not that much interested in this. It is saying that you have run model 4, where y was your performance dependent variable, x was your creativity, and mediating variable was your innovation. The sample size of this is 250, and then it's going to give you some of the initial analysis which we've just seen in our regression analysis. For example, r square value is here. And how did it perform the regression? Creativity and performance, one model with r square value. Fine, you can just look at it afterwards. This is the t value, p value, and then we'll also talk about these two terms towards the end. But we are not interested in that model. We are not very much interested in this model. You can also use them and do not run your regression, but currently we're not very much interested in these models. So it's going to run a few models, but here, if you can see that it has given us this table. Now, this is the most important table in order to understand the mediation results. It says total, direct, and indirect effects. What were our variables? Our variables were creativity, innovation, and performance. Let's just look at this again: creativity, innovation, and performance. And please make sure that you understand the difference between direct, indirect, and total effect. Now, let's just go to our analysis window and see what are the results. Now it says the total effect is this one. These are the results of total effect. This is the effect, standard error, the t value, its significance, and some two more types of values, LLCI and ULCI. Uh, we'll talk about these two in a minute, but let's just look at the other values. The direct effect of x on y. What's this? It is 0.1299. The indirect effect of x on y is this one. Total effect 0.7982. Direct effect 0.1299. Indirect effect 0.6683. Now, how do we further interpret it? As we've already understood that indirect effect plus the direct effect are equal to total effect. Now, let's just note down these values, and if we can go to our this point. Now here we actually mean, how about this direct effect? I've taken the values from there. Now this is the effect which is going from here to here, and we are saying it is 0.1299. What about indirect effect? Indirect is the effect which is going from here through here till here, and this is known as 0.6683. Now, there are going to be a few more concepts that we must understand. How do we say, after looking at these three results or three values, the total effect, direct effect, and indirect effect, that if we have accepted our mediation hypothesis or we have rejected it? How are we going to say it? Now, let's say that these values of indirect effect, if they are significant, we will say mediation is taking place. Yes, this is for sure. But is this mediation a partial mediation or a full mediation? Now, let's just understand another term, full mediation and partial mediation. Now, let's suppose if this path is significant, which means there is some mediation result, and we are concluding that effect is moving through the mediate to the dependent variable, and this path is significant. We'll talk about how we determine its significance. And this part is not significant. For example, for now, we will say that there is full mediation because all the effect is being transferred through the mediator. There can be another scenario. What if this path is significant and this path is also significant? Then we will say that there is partial mediation because we have a relationship directly as well as directly, as well as indirectly. So partially effect is moving from here, partially effect is moving from here. The third situation can be that this path is significant, this is not significant. Then we'll say there is no mediation. There's only direct effect. Or another thing can be that this is also not significant, this is also not significant. Then we will say that independent variable is not related to dependent variable directly or indirectly. So this is how you actually determine the full mediation or the partial mediation. Now let's just go back to our analysis and determine how can we say that our values are significant. We can say if our values are significant or not by looking at a few things. First, we will look at the direct effect, for example. Now, direct effect is saying the effect, which is the beta that I mentioned when we were talking about beta in regression. This is the same as beta. It's just given a name of effect. Now, if you look at this and you look at its corresponding t-value, it is saying that it is significant above 2 and the p-value is less than 0.05. So both the indications are there which are telling us that this effect is significant. Furthermore, when we are using this bootstrapping method, we also need to look at these two values. These are very important values. What do we call them first of all? LLCI and ULCI. LLCI means lower level confidence interval. ULCI means upper level confidence interval. But how do we actually interpret these two values, and how do we determine that if our values are significant or not. Now, simple way of understanding is that if both LLCI and ULCI have the same sign, then values are significant. Then you are fine. Then you can accept these values. If the sign of LLCI and ULCI is the same, sign means either both of them are positive or both of them are negative. Both ways, if they are having the same sign, it means your values are significant. But if they have one value has minus sign, the other has plus sign, then there is a problem. Then it is insignificant. So if you look at this total effect, it is significant. If you look at this direct effect, it is significant. If you look at this indirect effect, it is significant because all three of them and their values are carrying the same sign. But the right explanation is the range between LLCI and ULCI should not contain 0. Just try to think about this statement. The range between LLCI and ULCI should not contain 0, which means let's just talk about it here. If we have a 0 here and a minus 1 somewhere here and a plus 1 here, now we'll have to look at the values of LLCI and ULCI. And let's just look at the values of LLCI and ULCI. Taking this example, 0.58, 0.5846, and 0.7609. So if we just place these values, 0.5846 will come somewhere here. This is the starting range, and then 0.7609 will come somewhere here. So this is a range from LLCI to ULCI. LLCI and ULCI. This is the range. This range does not have a 0 in it. 0 is somewhere here. But if we have something which is in minus and the other thing which is in plus, obviously the range between the two values will have 0. Therefore, we are going to say that the values are not significant. Or, as we just talked about, you can also say that both values should have the same sign. If both of them are towards negative, the range will not contain 0. If both are towards negative, the range will not contain 0 because 0 is here. So you can easily say that you have the significant values. So this is how you actually interpret your LLCI and ULCI. Now, just a question after looking at this table, I'll be waiting for your answers. What kind of mediation is this? Is this a partial mediation? Is this full mediation? If or it's no mediation? What do you conclude out of this result of mediation? I'll be waiting for your answers. Remember what we talked here. Okay, we have one answer which is partial mediation. What about other people? Okay, we have another answer on WhatsApp that it's a partial mediation. Good. Okay, fine. So I guess it's somewhat clear to you. Now, looking at some, let's just go for some random mediation results, and we will see that if we have some kind of understanding. Okay, now look at these results, these new results, and then you can tell me that if you can understand the difference between what is happening here. Look at this LLCI and ULCI values, three of them, and tell me if all of them are significant, first of all, and then tell me that what kind of mediation is happening here or what kind of effects are happening here. Now I've taken formalization as an independent variable. We have another question or maybe a statement. If there is no direct relationship, then this is partial mediation. No, if there is no direct relationship, then we are going to say it is full mediation. Okay, this is also partial. Fine, right? So all the values are significant? Yes. Okay. Okay, right. So this is all about simple mediation analysis. Now we are going to move towards our moderation analysis. So first of all, in order to run our moderation analysis, we will say that we will be using model 1, and creativity is going to be our independent variable. Innovation is going to be our dependent variable, and culture, which is creative culture is going to be our moderating variable. So let's just go to our, yes, indirect effect is negative. Yes, you're right. Because indirect effect negative is saying, because I had taken the formalization as my independent variable, which is why it is saying that formalization negatively moderates between creativity and innovation and performance. So yes, it is negative. That is why I have performed this analysis, so you have a clear idea that there are sometimes these kind of effects. Okay, so back to moderation. This is going to be our moderation now. Creativity is our independent variable, innovation is our dependent variable, and creative culture is going to be our uh, moderating variable. The results of moderation are a little further complicated to understand, but once we do it, we'll have a very clear idea. So, analyze, regression, Andrew Hayes process, and let's just reset it. Now, here we need to be very sure that our independent variable is creativity. That's going to go here. Our innovation is going to be dependent variable, which is going to go here. And our culture is going to be here in the M variable. But because we are performing the moderation analysis, the model we'll be using is the model 1. Model 1. When we'll put model 1 here, then this M will be considered as the moderating variable. So let's just, we don't need to change anything for moderation. Let's just click OK. And we are waiting for the results. Now, there is one important term that we need to look at before we, let me just copy and paste into the Word file. Now, this is the analysis that we have performed using model 1. It is saying that you have used model 1. Y is your dependent variable, X is your independent variable, and M, which is moderator now, is your culture. Sample size is 250. It has run a few analyses for you. One important thing to understand here is this term. This int underscore 1 is actually indicating the interaction term. Now, what is the interaction term, or what is the interaction variable? It is actually, the interaction variable is actually a new variable which has been created by the SPSS. How did it create it? It created it by multiplying the data of independent variable with the data of moderating variable and then converting it into one variable. Again, the interaction term is created. This interaction term, sorry, we're going to, this interaction term is created by the multiplication of the independent variable and the moderating variable. And then it has been regressed with the dependent variable. Here you can see that interaction is the product of creativity and culture data. And what we can see here is that interaction term should be read first. And we need to make sure that interaction term is significant. So in this case, our interaction term is significant. What are the reasons? The effect is, or the coefficient is 0.2032. Standard error is far less than the coefficient. The t-value is significant, or you can say it is above 2, but it should be said that it's significant because it has 0.05 or less value. And again, the LLCI and the ULCI both are having the same sign, or the range between these two does not carry the point 0. So this is a good sign that we have the moderation. Now let's just move to downward table, and it is saying that R square increased due to interaction. Because of having the moderating variable, how much R square has changed? The R square has changed, uh, that is 0.0184, which is about 2%. Not a very good change, but still it is changing. So this we can interpret. But the most important thing to see here is this table, this one. Let me just correct it a little because it is giving us some problems of reading the data. Now it is fine. Now just look at this table. Now it is fine. Look at this table and try and understand what is happening. Actually, these three values, these three lines are representing the relationship between independent and dependent variable at different levels of the moderator. Now, how do we understand it? Let's just go to our model. What we are saying is that IV and DV are related to each other. Fine, it may not be having any relationship. But how does this moderator affects their relationship? Okay. So first value is actually indicating that when creative culture is least present, what is the relationship between creativity and innovation? When it is least present. What then the second value is telling us what is the relationship between creativity and innovation when the culture is moderately present. And the third one is saying that what is the relationship of creativity with innovation if creative culture is fully or mostly present. Now, let's just look at another thing. It's very important to understand this concept. Then moderation is nothing. Okay. Now here we are saying, for example, for the first line, which is the least level of moderator's presence, the effect is this one. Now, why do we call it least? Remember, we were using 5 point Likert scale. So people were answering from 1 to 5. 5 means the most presence, and 1 means the least presence. So here, people might have answered between 1 to 5. It has taken 3 levels of those people. People who answered somewhere from 2, 1 or 2, which means the creative culture was least present. Then people who said that it is somewhat present. And then people who said that it is present. This is towards the agree side, this is near the neutral side, and this is towards the absent side. So when the now start from here, the first, and then we'll move towards the third line. We are actually saying that when culture was not present, the relationship between creativity and innovation was 0.7594. Fine, good. When the culture is moderately present, we are saying that 0.9213 level is present. And when the culture is more present, we are saying that the effect between IV and DV is moving to 1.0832. So if you just look at the trend of these three values, when the culture is not present to when the culture is present, the values are actually increasing. So let's just go back to our example. And here, if you can see, now, here we mean to say that what if the culture is least present? We are looking at this value. When the culture is least present, value is this. There is a relationship, but when we improve this culture, there's more presence of creative culture, the relationship increases further. But then when there's full presence of the culture, the value is further enhanced. Therefore, with the presence or absence of this variable, the relationship between these two variables is changing. So this is how you actually interpret the results. Uh, I can see one question there. I'll just be answering it in a few minutes about the z value. So this is the moderation analysis. I'll just run another analysis for you, and then we'll see how much you have understood. And let's just take some other, let's say, formalization as the moderator. Let's run the analysis, get the results, and then you're going to interpret these results. Let's just run another one. I want some results to be different. Okay, so this is some different or interesting results. Now, looking at this table, you need to give me the answer that what is happening here. Is the relationship moderating positively or negatively, or what is happening? Okay, we have another question about. I'll just write down your question and we'll be answering it towards the end. And the question is that how do we take into account if we have more mediators than moderators? So first look at this moderation result and give me the analysis. and then I'll be answering these questions. Okay, negatively moderating, we have one answer. Because when you look at the change from the absence to the presence, it is negative. Yes, you're right. Negative because of the effect is negative. Yes, you're right. Okay. Okay, the effect is decreasing, so it's not a good moderator. It might be a good moderator, but it's a negative moderator, which means with its presence, the relationship between two variables is decreasing. That's the problem, or that is how we interpret it. It might be a good moderator, it might not be a good moderator, but it is how we interpret them. Negative moderator, yes. Model summary, if you can explain a little bit more, what do you mean by model summary and what values do they present in model summary, then we can talk about it. So this is about our mediation and moderation analysis. Few questions which are also related to the same thing. First of all, the question of the z value. What is the z value in the moderation? So z value can be treated as the t value. Let's just run another mediation. Let's just suppose that this is a mediator and we have the analysis. Z value will not be coming for normal analysis of mediation, but once you're going to have this option available to you, which is known as Sobel test. This is also known a mediation test. If you active this option of Sobel test, then it is going to give you the z value. Sobel test is actually used for the confirmation of the effect. So here you can see that we have got normal theory test for indirect effect, and there is the z value. This z value is actually uh, you can say like the t test. This is a z test, but the values are the same in terms of interpretation. The value of z should also be above 2, and here if you can see that value is not above 2. Or let me just run another analysis of some good. We can take this as a moderator and performance as our dependent variable. So here, when we'll get the Sobel test, it is going to give us the value of z, because with the indirect effect we are not getting any value of t, so it runs the z test. Z test and t tests are different Because t-tests are known as parametric tests and they are done on normal data. Z-tests are the non-parametric tests which are done on non-normal data. So that is why it's Z, otherwise it has the same meaning. Then we have another important question which requires a lot of attention for most of our students and researchers, is that what if we have more than one mediating variable or more than one moderating variable? Yes, if you have a model like this, for example, it has one moderator. If you have a model like this, it has one mediator, one moderator. But let's just look at this model. It has one mediator and one moderator. So what kind of test should we run? Now, first try and understand that what kind of hypothesis you are generating, which means that I am saying that I am only interested in knowing the relationship between this and this, this and this. So these are going to be my simple hypothesis. And I'm also interested to know the mediating role of this variable between these two variables. Then I'm also interested in knowing the mediation relationship. And I have another hypothesis in which I am saying that this moderates here. Then I have another hypothesis. So for this kind of model and for these kind of relationships, what you'll do is you'll run a simple regression for this, simple regression for this one. You'll be testing your two hypotheses. You'll be going to model 4 to analyze the mediation results of this one separately. You will be going to model 1 to analyze the moderating hypothesis of this variable between these two variables. So you'll have to run 4 different tests in order to test 4 different hypotheses. But most of us do not understand that there are some models in Andrew Hayes template. For example, if you look at this model, model 2. Now, if this is the situation in your theoretical framework, please do not misunderstand that your hypothesis should be guiding you what kind of model you will be using. Model 2 will only be used when your hypothesis is saying that these two moderators at the same time moderating this relationship. If you're saying that thing, then you'll be using model 2. But if you're saying that this is your one hypothesis, that moderator 1 will affect between IV and DV separately, and model 2 will be moderating between IV and DV separately. So if you have two of these hypotheses as moderating variable, you will be testing two models, model 1 once and model 1 again. Model 1 keeping this as moderator, model 1 keeping this as moderator separately. That is how you'll be able to manage your two separate moderators. Now, most of the peoples are confused in these models, which is model, this is known as sequential mediation, and you can always watch one of my videos on sequential mediation model. Now, most of the people are confused in this model number 7. What if we have a moderator here and a mediator here and IV and DV here? Please try and understand, if your hypothesis is saying that this mediates between X and Y, it's a separate hypothesis. And if you're trying to say that this moderates between this and this as a separate hypothesis, then you will be running model 4 for your mediation, model 1 for your moderation, in which this is going to be your independent variable and this is going to be your dependent variable. But the concept of this model 7 is not that simple. These kind of models can be hypothesized as moderated mediations. Now, for that, you only come up with one hypothesis, which says if W will moderate here, then M will mediate between X and Y. So this is your one hypothesis. So if you have made a hypothesis which is moderated mediation hypothesis, then you will be using model 7, and this will only be testing your one hypothesis. The same way, if you have this kind of model in which you are saying that both of these mediators simultaneously mediates the relationship between independent and dependent variable, then you will be using this model 6 with 2 mediators, model 6 with 3 mediators, and so on. So this is how you actually take care of your variables. But you need to be very clear what kind of hypothesis you have made and you are interested in analyzing. Otherwise, you will be totally misguided as in terms of the model numbers that you're trying to analyze. Let's see, we have if we have some more questions. Is there any threshold value which show about moderator should be accepted or rejected? Uh, there is threshold is, you can say that values should be significant first of all, and there should be a change from the absence of the moderator effect to the presence of the moderator effect. If there is an effect which is changing from the absence to the presence and the values are significant, then you will say that moderation is taking place. But for mediation, some people say that the indirect effect should be at least 20%. If you take the total effect and the indirect effect should be 20% of the total effect minimum. Some researchers say that, but others say that if it is significant, you can consider it as uh, your mediation. But some say, and many believes that uh, it should be 20%. The indirect effect should be 20% of your total effect. So in this case, it is how you can calculate it. You can divide the indirect effect with the total effect and then multiply it with 100. So you're going to get a percentage of your indirect effect. Okay. We have another question. If the moderator is negative, then it is bad moderator, but we cannot say that moderation is rejected. How to interpret the results then? Okay. If you had hypothesized, that the presence of this variable will increase the relationship between these two, but the results are otherwise, which means they are decreasing, then you are going to say that it's a it is not in the expected direction, so therefore you will reject your hypothesis. But If you had just made the hypothesis that presence or absence will make some difference, and now it is making negative difference, then it is fine. You can accept your hypothesis, and then it is fine. Yes, different model, smart PLS. G. If you're using your SEM analysis, SEM, which is structural equation modeling, then you get all of these results at once. Yes, for example, uh, I know about war PLS, in which you can just run one model and it's going to give you all of those results. We'll talk about that. In fact, I'm going to give you a full training on war PLS sometimes, but very soon, within I think a week or two, you will be hearing from me in one of my video playlists for war PLS, and in that we will talk about the SEM analysis, the structural equation modeling. Okay, we have another question. Common method bias, and yes. Okay, if you are already running your analysis in SEM, then you should not be running your common method bias separately. Then what you need to do is you can just go for your model fitness, your discriminant and convergent validities, your CR values, and your AVE values. But if you still want that you need to run a separate test for common method bias, what you can do is you can run a Herman's test. And the method for that is that you will go to analyze, scale, oh sorry, analyze, dimension reduction, and factor. And in the factor, what you can do is you can just place all of your items here, and then you can go to this descriptive, and you don't need anything here. You need the extraction should be your alpha factoring fixed number. For example, if I have it 3 here, 3 variables, I can just give it a number 3. Continue, rotation. I don't need any rotation for this analysis only. So I'm just going to continue and I'll press OK. It's going to give me some results. And what I need to see is the total variance explained section. And the first one is saying 37.104. Now, according to Herman's test, if this value, which is percentage of variance change, is less than 50%, there is no common method bias. If this value is less than 50%, now in this case it is 37.104, which is less than 50%, then you're going to say that there is no common method bias. So if you want, you can perform this test, and that is going to give you some support in terms of your common method bias. But otherwise, uh, you can also report this one, but prefer using the SEM results, in which you will be giving the CR values, composite reliability values. You'll also be giving the AVE values, and then you'll be giving your loadings and how those loadings are loading on different items. Yes, in the dissertation you can put these tests. If you do that, obviously it is going to give you some more clarity, and also the reader some clarity. Okay, we have not three variables, all the items are going to be put to the pan for factor analysis. Okay, then there is a request to repeat the concept of 20% mediation results. I hope you have understood the difference between indirect, direct, and total effect. If your indirect effect is 20 or more percent of the total effect, then you will say that your mediation is accepted. This is according to some of the researchers. Not everybody uh, believes that. So if you look at this indirect effect and total effect, what you're going to do is you're going to multiply the indirect effect, divide it by 0.7982 and then multiply it with 100. It is going to give you some percentage. The percentage is going to be, for example, I'm just going to calculate 0.6683 divided by 0.7982 multiply by 100, and this is 83%. So this is very good. It is 83%. 83% is definitely more than 20%, so this is good. It is fine. You're also going to see these percentage values of mediation in some of the papers. This is how they actually calculate it. Any other questions? I'm waiting for more questions. If you have any questions, please ask me. Okay, we have another question. If the models are not serial mediation and moderated mediation, for example, I have three IVs and one DV and one moderator, and I want to test the three moderator variable on three IVs, then how to perform. Okay, I guess what you're talking about is this kind of model. I'm sure you're talking about this kind of model in which you have three independent variables and you have a dependent variable here, and then you have a moderator, which is one moderator, but it is moderating at three different places. I hope you're talking about this one. If this is the case, then, and if you're not using the SEM analysis, what you can do is you can go with multiple regression of this, and this with this one, multiple regression, and this multiple regression is going to test three of your hypotheses. Then model 1 can be applied for this moderation separately, model 1 for this separately, and model 1 for this separately. But if you want to use a better method, what you can do is you can go to your SEM model and then place all of your IVs and DV, and then place your moderator and their relationships and just run one model. Although the method that we are just talking about, the Andrew Hayes, that is also very powerful and can easily be used. But you need to look at your requirement and your supervisor's requirement. If they want you to perform SEM, that can give you all of the result of all of your hypotheses in one go. But if you want to go with the Andrew Hayes analysis, then you will have to go with one multiple regression with three variables, and then three separate model ones for three separate moderators. I hope it's clear, and if anyone has any other question, now the idea is that you need to do these analyses, because this 2 hour, 2.5 hours training might not be enough to rigorously make you understand the analysis part. So I advise you to please download the SPSS, download this macro, try different data sets, try different analysis, and then try and interpret them. And obviously, the recording will be available on the same link. So unless you try it, unless you use your SPSS and other things, it's all not going to be very beneficial. People who are doing their thesis, they have a very good chance that they are learning and also they are applying. But people who are not doing their thesis should spare some time and do these analysis. So by the time you reach your thesis time, you'll have at least some idea. And the recording of this will be available on the same link. You can anytime you can come back and you can watch this training. The first part is already there. The second part was today. I'll be waiting for 1 to 2 more minutes. If you have any question, end note, I'll ask someone to share it with you. Okay, I'll also upload the slides here so you can have a clear idea. I'll just leave a link through which you can download these slides. Anyone else? Any question? With the rough work, I'm not sure if the rough work is going to be there because I keep on deleting it. But still, I'll share the slides. And if there's any confusion, you can ask me. There can be a third part if you people are interested. We can perform some analysis like sequential mediation or moderated mediation, or if you want something else, you can always let me know and then we can have the same session. Smart PLS, I'm not sure, but yes, we can have a warp PLS training maybe in a couple of weeks' time. I'm also developing a complete course of warp PLS. I have almost recorded half of the videos, but because I just want to put all of the playlist once, so I think within a week or two you'll have a complete list of warp PLS, which is obviously a more powerful tool than SPSS, and definitely is going to be there on the same place. You can come back after week or 2 weeks time, and you'll find it there. Okay. If you have any question, it is fine. Otherwise, you can leave. Thank you very much, everybody.